Let's learn about unit tests. Once you've created a function, how do you know if it is correct? You could carefully read over the function, but you might miss something. Instead, programmers use collections of unit tests to determine if their code works as expected. Unit testing is an important professional practice to help you find problems early, facilitate changes down the road, and make it easier to glue together pieces of code. A unit test is pretty simple. Call a function with a known input and compare the result to a known output. For example, consider this function that converts feet to inches. Above, the function call is a special statement that imports, or makes available, the assert equal function from the test module. We use this function on the line below to write our unit test. We call feet to inches and pass in 2, and assert that we expect a result of 24. A tricky part of making unit tests is thinking of appropriate test cases. The goal is to cover as many possible scenarios, while writing the minimum number of cases. In our conversion function before, we tried it with a small positive number, a decimal number, a negative number, a large number, and a 0. These are all representative cases. Depending on what our function is doing, you might need more or less test cases. When you write many unit tests, you increase the coverage of your code. Coverage is usually measured by the number of lines of code that are executed, divided by the number of lines of code that you've written. Right now, as long as you write any unit tests, you'll be able to get good code coverage. Soon, we will see that you need to write more unit tests to handle loops and conditionals. When a unit test fails, it should report the actual and expected values, so that the programmer can then debug their program. If you only try a function with one output, you might think that the function is correct. But until you run unit tests, you shouldn't believe that. Of course, unit tests are not conclusive either. They are merely evidence to support the hypothesis that your code is correct. The larger your program, the more important it is to unit test individual pieces. However, unit tests are also helpful as you learn the basics. Every program you write in this course will be unit tested, which means that we will try running your program against many inputs and outputs. Sometimes you'll be asked to write your own unit tests, and sometimes we will run our own unit tests on your own code. Just because your program appears to give the right output, you must still pass all the unit tests.